Hi everyone. Today we're gonna discuss the line-to-line collision detection with hit points, and this is the part one of the video. The part one of the video basically investigate um, the forming of two linear equations. Now, since we're dealing only with 2D graphics, we just have to deal with x and y equation, which is linear graph. So I believe in secondary school, most of you would have learned how to solve simultaneous equation for two linear graph. All right. So, but in this case, what we're going to do is we're going to learn how to solve it using computers. So the knowledge that we are going to require is forming a very simple two-dimensional uh, matrices to represent the um, equations for two lines. Then we'll use a very simple method, which is the inverse matrix, to solve these two. But that will be discussed in part two. So first, let's take a look how we can represent uh, two lines in the computer, all right, using simultaneous equation. All right, so let's get started. Now I've uploaded the slides in together with the video that I have discussed. So let us take some time and discuss this thing. Now in computer, the points, 2 points is used to represent a line. So you have a line and they have 2 points. In this case, you can put an A and B. And 2 points has two coordinates. We call this x1, y1, and the other one x2, y2. Now, assuming that these two lines actually intercepts with each other, which we have done earlier, you have another line which is C, x3, y3, and x4, y4. So you have two coordinates C and D. All right, each of them with coordinates x3, y3, and x4, y4 respectively. Now, to start off the discussion, let us see how linear lines is being represented. Now, in linear lines, what we have here is um, linear lines is usually represented by an equation y. Oops, it went down to the. Okay, there we go. Right. Um, I think I need to get a writing anti-glove so that as I write, I won't touch the screen. Okay, now what we have here is normally lines is given by y equals to mx plus c. Okay, where m is the gradient of the graph and c is the y-intercept. But since we're given only two lines, or rather 2 points, okay, for a line, um, it's impossible to substitute these values into this equation. A more general equation for a linear graph would be you take y, something wrong with the thing. Okay, you take y minus of a coordinate, let's say y1, all right, will be equals to the gradient, all right, and x minus x1. So in this case, I've just formed an equation for line 1, and where m is equals to y2 minus y1 over x2 minus x1. So this is the first equation, and this is the second equation. We're going to apply this into our Visual Studio C++ in a short while later. So now here, what we have here is a method and these things. From here, actually what we can do is we can actually form an equation for a straight line. Okay, so to keep things simple, we let A equals to y2 minus y1, and we let B equals to x2 minus x1. So we have equation 3 and equation 4. Okay, so this is the thing. Now, of course, we can rewrite all these things using the thing here. So substituting, all right, uh, basically 3 and 4 into 2. So we have M is equals to A over B. Okay, so this will give us equation 5. So substituting 5 um, into equation 1. So what we do is substitute 5 into 1. Right, and we get y minus y1 is equals to m is a over b, so it's a over b, and this is x minus x1. Now take note that if we use a set of coordinates, say x2 to represent this equation, it will work as well. So long as there is a point that resides in line 1, and we'll be able to get the answer. So with this, what happened here is let's rearrange this whole thing inside by taking b up. So we have by minus by1 equals to ax minus ax1. Okay, so rearranging by putting all the x, y, and x on each side, what we have here is by minus ax is equal to by1, all right, minus ax1. Now, in fact, we can rewrite this whole thing into a matrix, all right? Rewriting into a matrix. All right, it's actually, we can put this thing b minus a, holding bracket, and we have x and y here. Okay, equals to our by1 minus ax1. Pardon for the space. But we'll talk about this in a short while later, which is the forming of the equation matrices for both of them, right? So cover this more in a short while. So very simply, let me recap. We want to represent the equations of a line in a 2D dimension space, all right, using x and y. So once we're able to represent x and y, we're able to use the matrix methodology to solve for the intersection between two lines. So the first part in doing it is to represent the two equations, all right, 2 points or two lines, okay, given 2 points per line and given 4 points to represent two lines. Given these 4 lines, we want to represent a linear equation for it. Okay, so this is how we go about doing it. The main bulk of the equation comes from here. All right, this is the standard equations for linear. Or rather for lines. Okay, and this is the equation for gradient. Okay, the rest a and b are just supporting variables so that when we do it later in the computers, all right, it's easier to represent all these things. So once you're able to do these things, you're able to represent it using a matrix, which is shown here. All right, so that's all for the video. Thanks for watching.